I'm Dr. Lydia St. Hill, and I'm here today to help you use Excel to create your graphs for your titration curves, and also to help you use Excel in order to do the calculations that you need for the two different types of tables that you'll need to fill in during your data analysis portion. Using the values that we obtain, which are going to be your pH value and your volume that is being added from the burette. Using those two values, we're going to be then able to plug in our formulas in order to extract the data that the rest of the tables need. Then we're also going to be able to plot that pH versus the values that we get for the volume, and we're going to be able to see the titration curves. We're going to switch over to Excel. You should be able to have access to this Excel document in the course modules so that you can then pull that data sheet up, and then while you're collecting the data during the experiment, you can go ahead and plug in your values and your observations. And then it's one less step that you would have to take later, because then you can just quickly plug in the formulas by watching this video to know what your values are so that your data can then be submitted into your data table. We're going to switch over to Excel. Once you have your data pulled up for the titration, we are going to calculate the moles of the hydronium ion. The concentration on our second experiment is a 0.05. So when we start looking at that, instead of having the 0.1 like we did in the first experiment, we're going to have 0.05. We are going to then start our formula, but in this particular case, since our acid is in our flask at the bottom, the acid amount is not changing in the hydronium. So we're not going to give it a cell to communicate with and change. So when we go ahead and fill this in, it's going to be the same value. We want to basically put the same formula in each one without having to type it that many times. We're going to start with going equals, and we want to make sure that we're using our volume in liters here. So we're going to take our 15 milliliters divided by 1,000, and we're going to get 0.005. We are going to put our equal sign, and we're going to go 0.1, and then we're going to hit the asterisk, which is the multiplication sign in Excel. And then we're going to go 0.005, and we're going to hit enter. So now we have the moles of hydronium, and this is what's sitting in our flask, and it's not changing. And then as we go down, it doesn't change, so it populates for us the 0.0005. So now, how do I get the moles of hydroxide? Well, initially, we're not going to have any in there because our volume is going to be no hydroxide. No sodium hydroxide was added. We're going to use that same equation, which is molarity equals moles over volume. So if we know the molarity and we know the volume, we can then calculate the number of moles of hydroxide. Our first one should get to be a 0. What I always recommend is going back and just using your calculator for the first 2 sets of data to very quickly make sure that your formulas were inputted correctly. If they're not, or you get errors, just go ahead and start over, delete everything, and then just go back and start your formula trying to put it in there again. We're going to tell it equals, but we need to give it a signal to go back to start looking at how much volume we added. So in this case, our volume is in milliliters. So we're going to have to add that division by 1,000 within our formula context. We are going to tell it our volume. We're going to start it off with parentheses and then add 2 more parentheses. This is because we have to use orders of operation to make it read the formula correctly. So we're going to have 3 of them. Then we're going to go ahead and select the volume, which is going to be in column B. So we're going to hit B2 because we're on row 2. We're going to close that. Then we're going to tell it to divide that number by 1,000. And then we're going to close that one off. Then we're going to tell it to multiply our value by our concentration, which in this particular case is 0.100. We did the standardization of sodium hydroxide in a previous lab. You obtained what your actual concentration is. This is where you would plug in your particular value. So if you had 0.101, then that's the value that you would use. For the simplicity of this, we're just going to use 0.100, but you would use your value. Then we're going to close that, and then we're going to hit enter. We should expect a 0 for the first one because we did not add any. But as we come to the top and we pull that down, we should start to see that we've added moles of sodium hydroxide or the hydroxide ion. We now have those values. But during our experiment, the moles of hydronium are interacting with the hydroxide and creating water, which means we're not going to be having that hydronium and that hydroxide. As the experiment progresses, we get to that neutralization, that equivalence point. That's where we need to make sure that we're going slow during that middle point in order to, one, get a very good graph, but two, also to get very good data. At the neutralization, we're going to start to see that we're going to be flipping over and having more hydroxide than hydronium. So our next column is going to indicate that by giving us some negative values when we fill in for the difference. This is what we're expecting to happen, so we're going to have to do something a little bit different in the upcoming columns because of this transition. And we know this because we start with the indicator color being this orange or this reddish type color, and then it should end with it being purple because we would have that strong base present that's more than the acid being present. We're going to hit equals to start our formula for the next column, and we're going to subtract column D minus column E. Enter. That's a simple formula. We expect 0 from 0.0005 gives us that same number. Then if we go ahead and drag this down and start to see that we get these negative values. Because we have such small numbers, it may be wise to go ahead and format our cells and add 5 decimals to see if maybe we can get a little bit clearer, more concise data from our experiments when we do our calculations. So now that we have formatted our cells by selecting the top, we come down, format cells, we select the number and then the number of decimals. That gives us our full values. But we start to see that there are negative values associated. That would be expected because we're starting to see that transition. So now we need to find our total volume, and we're going to do that by adding our 15 milliliters to our volume of our base. And when we do that, we're going to still have to get that into liters by dividing by 1,000. So to start our formula for the next column, we're going to hit equals, and then we're going to do 2 parentheses, so 2 open parentheses. Then we're going to tell it to take 15 plus our volume from column B. We're going to close the parentheses, close it again, and then we're going to divide it by 1,000. We're going to then select the top column and we're going to bring it down. And now we should have our total volume in liters. You're seeing that some of them are not all the way there, so we're going to go ahead and go to format cells. We're going to select number. We're going to go ahead and give it 5 decimals, and everybody should have the same value so that we can use true comparison very easily. In order to get the concentration, we're going to take what we have for the hydronium ion, and then we're going to divide it by the total volume. In order to get our values, we're going to take our moles, which is going to be column F, and we're going to divide it by G. So this is going to be equals F, and we're going to hit the slash for divide by column G. We're going to hit enter. You got to be careful when you're working with Excel, because if you click any other cell when you're working in a formula, it will change your numbers and then it will confuse you. If you're not sure, you always start over, you go equals, and then you select your difference in moles, which we know in this case we have more hydronium because it's not negative. Then we're going to divide it by the total volume, and we're going to hit enter. We can then drag this all the way down until we start seeing those negative values, because once we get those negative values, we're not seeing the hydronium anymore. The hydronium should be used up at this point. What we're going to be getting is our hydroxide thereafter. We're going to switch over to the hydroxide column, and now we're going to tell it equals, because we want to know what the hydroxide ion concentration is. We're going to then switch over to this column, and now we're going to do the same thing there. We're going to take the moles, but in this case, we have to get rid of this negative value. So we're going to multiply it by -1 to make it positive without changing the value, but getting rid of the negative sign, so your formula works great. So you're going to hit equals, and then parentheses, 2 more, and then you're going to put a -1, close your parentheses, and then we're going to put a star, and then we're going to hit our difference in moles, and then we are going to close our parentheses, and then divide by our volume. And then we're going to close the parentheses again, and we're going to hit enter. So now fill in the rest of the column with that. We can see that split with that negative value. We see that we have our values here. Looking at our data, obviously I'm not going to have pOH values here, but this concentration of the hydroxide being present is going to give me a predicted pOH, and from there I can calculate the pH. For this top part, all I have to simply do now is, for this column, is plug in your data, and the pH is equal to the negative log of the concentration. So to get our predicted value of pH, we're going to hit equals negative log. So it's showing you that we've got that log value. And then we're going to put in parentheses the value that we want to use, which happens to be column H. And we close it off and we hit enter. So now it's giving me a predicted pH, and I can go ahead and fill that all the way in until here. Now if you notice, it's not giving me a numerical value because we're at that 0 mark. So we're going to delete because it's not going to give us that value. And then we're going to come over here and we're going to do the same formula, but we're going to do it for the pOH, and then we're going to calculate the pH. We're going to go equals, once we get that hydroxide concentration, we're going to go negative, and then we're going to hit log, capitalized, it's very important, it's capitalized, open parentheses, concentration, close parentheses, enter. And then we'll just fill in the rest of it. Once you do that, then you can come over here and you can get the predicted pH by hitting equals 14 minus my pOH, enter, and then getting the values. So now all you have to do at this point is plotting. Insert, you're going to select your column, which in our case is going to be the volume, column B. We're going to hit Control C, and then we're going to hit Insert, Charts, Scatter Plot with the line. And then of course we can change by adding axes, axes titles, chart title. And then if we want to do the trend line, we can do the 2-period moving, and it gives us the difference. If you get that extra line on there, you can just click on it and hit delete, and it disappears. So you would label your chart titles, which is your titration curve, your axis titles, which is your volume in milliliters versus your pH, and you can get that nice curve that you see. Trend line kind of helps you. If you have enough data points, it should be very smooth. It looks like we may have gone a little bit too fast during the midpoint here. Hopefully this helps you, because you're going to be doing the exact same things for the next 2 graphs. Just make sure that you're using the right concentrations. Hopefully this will help you quickly fill in your information in your charts. If you are looking to add this into your data table, you can simply select the graph and you hit copy. If you're wanting to insert this table, you would simply select your data by highlighting the cells that you want. You can go copy, and then you can just paste this table into your data analysis so that you would have that. Or it may be possible that your instructor just tells you to upload your Excel sheet. Make sure that you pay attention to what your instructor is having you do. Otherwise, this should be pretty easy to get your data without doing a lot of work.